All right. Welcome back. My name is still Jon Jahren. I'm still a database architect working at Microsoft. For those of you who are new here, just a short introduction. I have about 20 years experience running SQL Server in different types of roles as a technical specialist. And I'm currently working for the largest customers in Norway, helping them with architecture guidance, proof of concepts, new technology, workshops, and stuff like that. This session is building upon my previous session today, where I talked about database as a service, and now I'm going to talk about running SQL Server on virtual machines. And how you can still get away with it. So, compared to what I talked about earlier today, you access a VM with SQL Server instead. You manage SQL Server, SQL and Windows Server with all the management and you have to self-configure your high availability settings and everything. You can run any SQL Server version and so on. And I'm going to start talking about how the SQL Server in Azure VMs work, because they have a lot of specific templates and specific properties that we want to understand. And then I'll move more and more into how to optimize your SQL Server environment in those Azure VMs, and move more and more into how you can apply the same principles in your on-premises virtual environments. All right, and I know this is the last session today, isn't it? Yeah, so I'll try to be finished a bit earlier, since I know a lot of you probably are eager to get home, but no promises. Things tend to take a while, but let's just see. Okay, Microsoft IT. Our own IT department had recently or has finished a large project about moving most of the MSIT servers into Azure, and they produced some interesting statistics about the success ratio, and it's the common 80-20 rule. So 80% of the workloads were fine, those workloads with no performance blockers at all. And then there were like something around 8% which had extreme I/O, which represented challenges that could be addressed with careful design of those VMs, but in some cases needed to stay as on-premises solutions. For example, Microsoft runs SAP. Do you know how large our SAP environment is? We have 193 SAP VMs that runs the environment. That's included, of course, development, test, training, and so forth. But only the actual SAP ERP SQL Server had to stay on premises, and most of the other workloads are VMs. So that's just some of the guidance that like a large corporation as ourselves has experienced, but your mileage will, of course, vary. Okay, so Azure VMs. In the Azure portal, you will have a set of templates for your SQL Server. If you look at these templates, let's just browse for everything related to SQL Server. You will see that we have pre-configured templates for the latest versions, SQL 2014, 2012, 2008, and also CTP3 version of 2016, which is very helpful for those of you who want to just test it before deployment. And we also have some pre-configured templates for setting up an always-on availability group. I'll get back to that later, because that's a very interesting prospect for high availability scenarios. So these Azure VMs, you can also build a VM, of course, yourself from just a pure Windows VM, or you can bring your own images. And it's pretty fast in Azure to provision these, typical few minutes, up to 10 minutes. And you pay per use, per minute, only when running. You can pause them and then you can restart them, and typically it only takes a minute or two to resume them. That's not always the case with all the services in Azure, which you can pause and resume. For example, Azure SQL Data Warehouse takes about an hour to resume in a lot of cases. So, this is definitely one of the better technologies to the pause resume story that we have. Okay, these VMs are elastic from the tiniest versions up to maximum of 32 cores, 512 gigabytes of memory. This, of course, corresponds to fractions of the largest servers that we have in our data centers. So if you start with just 132 part of the server, and you can scale up to reserving the full capacity of a G-series server in, for your VM. In Azure VM, every VM disk is a Windows Azure storage blob, and we have 3 local copies of every VM disk that make sure that you have 0 data loss and a high available solution in regards to the VM disks. If you have geo-replication enabled, we will also have 3 more asynchronous remote copies in another data center. But by default, these local copies are in a local data center. Recently, we started also to have these local copies separated by physical buildings. So we have these fire alleys, brandgater, between the physical buildings. Because as many of you have heard, we had a fire for some while ago. So we had a building that burnt down, and after that we started placing these local copies on each data center in physical buildings separated by fire routes. Okay, as themselves, the Azure VMs, we say that they have 99.95% availability. So we reserve the right to have some planned downtime due to host OS servicing, and have some overhead for physical failures. And if you need more availability than that, you need to implement in a practical sense, the only viable solution is using availability groups currently. So you replicate the SQL Server VM and I'll get back to how this actually works. So based on customer feedback, you will gain about 99.99% availability on always on instance of a SQL Server VM. These Azure VMs, by default, they have IP address that is exposed on the internet. We recommend using network ACLs to protect that at a level higher than that, or to use a VPN tunnel to your from your internal network to the Azure data center in order to extend your on-premises network securely to your Azure VMs. So you can join your Azure VMs to your on-premise domain. And typically in that kind of hybrid environment, you will also have your domain controllers also synced with a secondary domain controller in Azure in order to have your services work with the same service accounts both in Azure and on-premises. So that's a typical environment for those. With that said, we're also working on a project now that is going to go into preview in a short time, which is private endpoints or private platform-as-a-service endpoints in Azure. I didn't talk about that earlier, but your Azure SQL databases and our platform-as-a-service offerings in Azure, they also have public endpoints, so their IPs are exposed on the internet. But we're working on a solution now that we have a private preview for. So we have customers testing this now, that where you have the ability to have this type of site-to-site tunnel and only expose those endpoints internally on those endpoints. That's the private platform-as-a-service endpoints project that I'm talking about. If you're more interested in that, you can talk to me later, send me an email, and I can make sure if it's interesting that you can sign up for the preview on that that one. So for the, as I showed you, we have many SQL servers supported, SQL Server versions supported, SQL 2014, 2012, 2008, R2, and so on. And those licenses are included with the monthly license that you pay. And for customers who have an enterprise agreement, they can also bring their own licenses and install them in Azure VMs if they want to. Now, last year we started also having a special image also for optimized images, where so these are pre-installed with the SQL Server installation, but those installations are not optimized for any specific workload. And as you know, workloads are in SQL Server, they have specific demands on how you configure the product. So we started first deploying or offering a separate SQL Server template for a data warehousing workload. But currently we've changed to just have a optimization step after you choose your VM, which is optimizes it for transaction processing or data warehousing, or just general, which has no optimizations. So just to show you how this works, if I here choose a template, let's just take SQL 2014, the latest one. I want to create an image with this one. Let's just give it a name. Demo Jon. I need to have a username password, so I can log on to it afterwards. I have an internal subscription here that I'm using. I'll choose a resource group for my resources. Let's just choose one of them. I'll just take South Central US. And understand that when you configure it in a location, there could be some limitations on the amount of templates that are available in each location. So if you choose like a smaller location, like the Singapore location or whatever, it could be that all the templates and the pricing tiers or so forth are not available in that location. But let's just accept these. Just wait a second. Now we have to choose the VM size, the pricing tier. And I see some recommended. Let's just expand to all. And here you see that the smallest sizes are 1 core, 3.5 gigabytes of RAM, 2 disks, and 7 gigabyte. Understand that that size there is for the scratch disk. So that would typically be the area for your temporary data, maybe some maybe your TempDB or buffer pool extension. I'll get back to that. But that's not necessarily that's not recommended for the place where you actually put your data. That's something you configure in the next step. So make sure that you're aware of that. That is only the local SSD for your temporary files, the scratch disk as we call it. And these D series here have premium disk storage. So these have support for our SSD storage. And if I go to the down here in the list, down in the bottom, I'll see the big ones, the G sizes, which in this, just as I showed you, which is not available in all locations. And the G5 is currently the largest one that we offer, which supports, which here costs 50,000 crowns a month, which is 32 cores, 448 gigabytes of RAM. And the G stands for Godzilla, of course, in our terminology. But the D series is perfectly adequate. The A series we currently do not recommend for production, but more for test or development and so forth. Because the difference here between an A1 core, so this is the older generation of servers, 1 core for the A series compared to 1 core for the D series is about 60% faster for each core. So the CPU speed and everything is much faster for the D series. So the D stands for doable, duger på norsk, but the G series is the enterprise class servers. Okay, so after we choose one of these, let's just take the D3 as an example here. Then we accept the defaults for our storage and network resources, storage account and the network resources. Let's see here. Oh, I didn't have a storage account in that location, so let's just give this a name. If we already had a storage account in this location, we would just get the option for choosing this. So, and now comes the interesting part. Here in the storage configuration part, we actually choose the, this is maybe the most important configuration, because here you actually decide what type and size and tiers for your data disks. So this is the data disks for your actual user databases. So as we draw the slider up here, you can see that for each terabyte there is added data disk, and you quickly reach the limit for IOPS. Since this is premium storage template, you quickly reach the limit for the IOPS, which is limited by the pricing tier of the VM. And we add disks here in order to get to the amount of storage that we want for our image. So if we need 4 disks, for example, we slide it up to 4 terabytes there. Then we can see the corresponding throughput and IOPS that we receive from that configuration. I'll get back to it soon. I just want to point out this very important here. And under here is the storage optimization. So under the storage optimization is some specific SQL Server settings that optimize your image for these type of workloads. Also, see here that we have this. We have the ability to set some automatic software patching, and automated backup for this, and automated Azure Key Vault integration for your secure store for your transaction for your encryption keys. And this is also we can set something we can set in the same picture. Now let's just accept this, and I'll get back to these concepts after we've just deployed this, and it should be ready in a few minutes. So the database optimization, for example, does the following. It improves, it sets the SQL instance with the trace flag -e, which enables larger extents per file. And then it sets the trace flag 1117, which makes sure that if you have several files in a file group, that these expand in parallel and grow sequentially. We also have maximum memory, which is a default set in the default image to the default setting, which just expands to the amount of physical RAM you have in the server. In the database optimization, it's configured to reserve some parts to the OS. Recovery model for your database is set to simple. Temp DB is set to 25 gig on each disk, and the temp DB log is set to 1 gigabyte. And there are some OS also disk and disk allocation, where disks are automatically allocated into one Windows storage space instead of you needing to map one data file for each disk in a specific file group. And so this is the data warehouse optimization. And typically we say that if you choose this for data warehouse optimized workloads, you'll typically get like a 20% better scan rate and about twice the throughput on clustered index rebuilds. And but your mileage will vary. But it's very important in these type of environments to use column store indexes, which I mentioned earlier, which is very important for this type, which was the logical design that was tested for this type of optimization. So, the optimization part in the VM configuration is very important. Let's see if it's finished yet. No, it's still deploying. So recently, the G series VMs are, well, we're up to recently the largest VM sizes in the market, which have up to 32 cores and 512 gigabytes of memory. And these also have the SSD support for TempDB and buffer pool extensions. Now these SSD support gives us about 5,000 IOPS per disk compared to 500 IOPS per disk for the standard storage. And also these support SQL snapshot backups, which I'll get back to, but is a much faster way of taking backups, which is a new backup technology that we will release in SQL Server 2016. Also, what we added was the recently was the Alwayson gallery template for availability groups. Earlier we had some guidance. We had some white papers about how you actually set up availability groups between Azure VMs, but that white paper was really complex. Typically, it would take myself would typically reserve at least 2 or 3 hours to set up an availability group in Azure. But using the gallery template, you will typically do it in 30 minutes to deploy a full availability group with domain controllers and everything. I'll get back to that. Recently, we also added Azure Key Vault for your database encryption keys and backup encryption keys, which is very important in order to make sure that you store them in a secure location. And we added Azure Active Directory support, so you can have your SQL Server logins coming from Azure Active Directory. Okay, so those are some of the recent ones. So the D series and the other ones come with they come with a local disk, which is your D drive. And this D drive is on the D series and G series VMs come with local SSDs, which give you up to 800 gigabytes of storage and at a very low latency. And this is very important for workloads that use TempDB heavily, and those TempDB can vary a lot between workloads. Actually, how much it is utilized, but typically, when you have transaction workload, transaction-intensive workload, or when you're using a lot of triggers, when you use a lot of when you implement row-level versioning, the snapshot isolation level in SQL Server databases, you will see you have a lot of TempDB traffic, and a lot of DBAs and database developers aren't really aware of the sensitivity of the TempDB database, especially in the latest versions when they enable snapshot isolation and so forth. Because in the TempDB there will be created a version store that includes all the previous versions of your row modifications. And also when you implement triggers, the inserted and deleted virtual tables that gives you access to your previous values in the triggers, they are implemented and in the same version store in TempDB. So it's very, very important that we have quick access to the TempDB, and then it will typically be the database that grows fastest and has is most sensitive for file growth in your system. So it means that since we have a local SSD, it will be it could be in certain circumstances the ideal place to put your TempDB. So the TempDB, to allocate it to the D drive, will just be an alter database command where you move the specific files, and they always have the same name, tempdev and templog, that you move to the separate disk, and then you need to restart your SQL Server instance in order to actually place it in the new location. Also, for the local disk, you can use the buffer pool extension. That was a new feature that we added in 2014, which means that SQL Server expands its buffer pool, which the buffer pool is the most important part of the SQL Server memory. That's where your data and indexes are actually cached. And what SQL Server can do is that it can place the clean committed pages in your buffer pool it can flush it to SSD drive, and in that way dramatically increase performance for new connections that need to read that data, and free your memory for the committed pages, and then get it from fast SSD instead of going to the slow database storage. So buffer pool extension is typically something we configure to about between 4 and 10 times as much as the physical RAM that's allocated to your SQL Server instance. So, and we it's a very simple server configuration statement to enable the buffer pool extension. So here in this example, we define on the D drive a file that's we call just the extension.bpe, when we set it in increments of megabytes and gigabytes, and then that file will be your level 3 buffer, level 3 cache for your buffer pool. So typically we will see a huge performance increase, especially for servers that have low amounts of RAM. Typically the sweet spot is 64 gigabytes of RAM or so forth. If you have a buffer pool extension for in like low RAM environment, you will see a large performance increase. So this scratch disk, the one that I showed you when you actually pick from the gallery the pricing tiers, this local SSD drive is ideal for those type of workloads. It's designed for those type of workloads. Okay. For the actual storage configuration for your data, this is not a local SSD, but we call it premium storage for the D series and G series. And these give you high throughput up to, for the G series, they announced that they are able to get up to 50,000 IOPS, 6 times more than standard storage, and at very, very low latency, about 10 times less than standard storage. And there are SSD disks in the back end. But just note that this is not the same as the local SSD-based cache, which is even faster. So typically, you will, for the largest VM sizes, you will get something up to 512 megabytes per second for 64K sequential reads, which is typically you have in a clustered index scan, for example. So also with the Azure VMs, you get automated patching, which is which patches your Windows and SQL Server. You only need to specify a time window, and it's built on top of Windows Update, and it automatically patches your server if you want to. This is of course optional, and you just set a maintenance schedule, and it takes care of that for you. Also, SQL Server templates can be configured with automated backup. For all DBs in the SQL instance, you only specify retention period and encryption or compression. And this is the same technology that we introduced in SQL 2014, that we initially in the beta or the CTPs in 2014 called Smart Backup, and then we renamed it by release to Managed Backup. So what it is that you just tell the SQL Server agent that you want a backup retention period of up to 30 days, and you want the backup location to be an Azure storage blob. And then SQL Server goes and checks the recovery level of all your databases. And if it's simple, it just implements a full backup schedule. If it's a full recovery model, it implements a full backup and transaction backup schedule, and then it throttles the amount of, or the interval of backups to align with the amount of traffic that goes to each database. So SQL Server makes the decisions on your behalf about how often we need to take backup, depending on the amount of workload on your databases. So this works well for DBAs that are exceptionally lazy, or have a very unpredictable workload on your databases. So it's not possible to predict how much activity you will have in the different databases. So you just want to have one solution that will work and adapt to the type of workload you have. So this is the automated backup that maps to managed backup in 2014. Now, let us also talk about the always-on template. So the always-on template, it bases on the principle that we need redundancy within a data center, which does is one part of the equation. The other part is that we also need redundancy to another data center. And SQL Server and the Azure VMs, in order to have full business continuity, we should have a disaster recovery solution that is always that is an availability group between VMs in different regions. And so typically, so you really, in order to achieve 99.99% availability, you should have an availability group that spans 2 Azure data centers, and typically you will have a failover between these in just a few seconds. Now, in order, as I mentioned, if you want to set this up by yourself, it's pretty complicated. It will take typically 3 hours or something. But using the Alwayson Gallery template, SQL Server can provision one automatically for you. The only thing you need to specify is a name for the deployment and a name for the availability group listener. So let me just demonstrate this briefly. So you go into the compute. Let's just see all. Let's see everyone based on SQL Server. And then we should have the template here. It's for 2014 only. And it configures domain controllers, 2 SQL Server instances. It configures the availability groups for us. So we need to have a name for the resource group. Let's just take a demo AG. My name, my password, my password confirmation, and then here we see the availability group name is suggested for us as the name of the host suffixed by AG. But let's just do it like that. And here's the listener name. So the listener is actually the in the connection string from the clients. This is the host, the SQL Server name that the clients can connect to. So if we're, for example, moving from an on-premises failover cluster and want to move into availability groups here, this will typically, and we have to want to have as little work as possible for our clients to reconnect to a new one. We could just use the same instance name as we used before in our failover clusters. That would typically be the migration path here. Just this corresponds to your previous instance names. And then here we have the pricing tiers for these. Let's just choose the and when we see the price loading, so the A3 or the standard one is much less than this, of course. Always On will come with a price premium because it's of course you use several VMs and so forth, but it corresponds to what you would have to pay if you picked these additional resources manually also. So there's no extra cost of using the Alwayson template. It just saves you time. And then we can just accept the other defaults, which just says that the SQL Server Service account can use the same password as I used for my username, and so on. And it also suggests that it sets up a domain controller for this. Let's just accept this and accept the location and so forth and create this. I just have to remember to turn all this off afterwards, or else I'll get a get an angry note from my manager next week that I'm spending too much in Azure. So very easy to set up your always-on deployments, at least if you only want to mirror your SQL Server images into in Azure. Of course, some customers want different types of solution. For example, they want their availability groups to span on-premises in Azure. For that, we already have a technology. In SQL 2014, we added an Add Azure Replica wizard within SQL Server Availability Groups. So it's very easy for you to take an on-premises SQL Server and put a replica in Azure. The reason a lot of people haven't actually, or reason more people haven't actually used that is because when you do that, our licensing policy is that you actually use one instead of having a passive failover server that you get for free, which is the normal policy for your availability groups. If you use an Azure replica, you actually have to pay a full license for that VM in Azure. So it's kind of the small lettering in the license agreements, that exception from the normal passive failover policy that we have. But just for an high available Azure deployment, it's a really great feature. Also note that these secondary servers, your replicas in SQL Server, may be used for readable access. So if your clients have an attribute in their connection string that says application intent, SQL Server may take access to the availability group listener and pipe it to the replica in your in your availability group. But when you do that, that actually triggers a license from us, because then you're not using one server and using the other one just as a passive failover server. In those cases, you're actually using both. So be aware of the license compliance issues you may face in that kind of situation. All right. So what about performance? Now in Azure, just as any VM environment, the network latency can be higher compared to on-premises. So that means that while we typically on an on-premises solution will move application layers on different servers, in a VM environment it would be sometimes we would sometimes need to evaluate if we could put this application layers on the same machine. What that means in reality is that maybe instead of putting the application server on one server and the SQL server on another, like a SharePoint server here and a SQL server on another VM, maybe in Azure or this type of data center, that we should consolidate the application layers and put them on a bigger VM. That is one typical architectural difference between these type of solutions. Also, it's very important to host VMs in the same virtual network and at least the same location, or else we're starting to get very, very big latency problems. Also, it's very important to drill a little bit into the data disk configuration. So typically, as I talked about earlier also today, a single Azure disk gets about 500 IOPS. Now those 500 IOPS are typically measured with sequential IO 64K extents, which is what you typically have as an access pattern when you do a clustered index scan or a non-clustered index scan, and you don't have too much fragmentation. Now you will have non-sequential IO, which is about the half of this if you have fragmentation, and you will also have 8K random IO for like random single row modifications and so forth in SQL Server. And these will of course have a lower bandwidth than the sequential IO. So you can't expect 30 megabytes a second for each data access, but it depends on what kind of IO pattern that SQL Server uses for each operation, and again how that corresponds to the bandwidth. So typically this table will be the measurement tests you will get for a single disk. So how do we expand over this? Yeah, so just to illustrate this a bit higher, IOPS is throttled by resource governor at about 500, so latency will increase as IOPS increase. If you try to write faster, you will quickly get queuing on your disk writes. So this is well known. We've always been very open about how this works, and it's important that we we work around the limitations instead of complaining about it. So how do we work with this? Yes, we then recommend a multiple disk configuration. So when to overcome those IOPS limits, to use either file groups with multiple database files and place each database file on a separate data disk. So each SQL Server database can have one or more file groups, and SQL Server file groups are just a container for one or more data files. And by default, each SQL Server database has a primary file group. So if you just add more files to the primary file group, as soon as you create the database, SQL Server will just spread all the data across those files. So it's kind of like database striping by default in SQL Server. So you just make sure that you allocate as many disks as you need for a certain performance target and place all those disks in the same file group. You can also have several file groups, and in SQL Server the create table and create index statement has an on file group clause, so that you can actually place separate tables and separate indexes on separate sets of disk drives. But typically you don't get a real performance optimization until you have a very specialized SQL Server, so I wouldn't recommend that just by default. It's not really in SQL Server, it doesn't really matter if you place the tables and indexes on separate disks or place them all together on the same amount of disks. You typically get the same performance. The most important here is just to access as many disks as possible, not necessarily to place them apart from each other. The second option here is to put an OS volume on top of the multiple data disks, so that SQL Server only sees one volume, but the OS then stripes over this. But SQL Server OS or OS striping has now been deprecated in Windows, so we don't recommend that anymore. The new technology here is Windows Storage Spaces. But I would typically say that you achieve exactly the same with multiple database files and with file groups. It doesn't really care for SQL Server's part if you use storage spaces or uses separate files in one file group. So typically you will get, if you have 4 disks, you can easily have linear scalability for the IOPS. So typically when you have 4 disks, you go from 4 or 5 megabytes a second to 20 for random IO. You will quickly scale your sequential I/O and so forth, but be aware that the sequential I/O will never move much, for reads, move much past 150 megabytes per second. So as we go from 4 to 8 to 16 disks, it will typically stop at this limit, but your writes will scale more linearly. So as you move from 4 to 8 to 16 disks and so forth, your random will increase, your writes will increase, sequential I/O will typically stop at around 150 megabytes per second, which is limited by the disk channel scaling and so forth. So smaller random operations and write-intensive workloads will dramatically increase performance with multiple disks. Another important thing is to be aware of that. What about this D drive? The D drive, as I talked about earlier, is the scratch disk, which is typically used for temporary storage. And some users they put data on the D drive that they shouldn't. For example, application binaries or production data. So be aware that the D drive will be lost when the virtual machine is moved to another host. So if you use availability groups, you must be aware that the temporary the data on the D drive is not persistent across hosts. So it is the best. So you shouldn't use production data there. You should only use the tempDB and buffer pool extension, but not the tempDB either if you're using availability groups. So, so the short answer is no. Predictable performance is even better if you have a separate data drive for this, but it comes it depends on the specific configuration. So how do we how can we increase I/O even furthermore in addition to or if we choose a pricing tier that has limitations for I/O, how can we work within the limitations that our pricing tier has? Well, one important thing is to use data compression. So SQL Server has page and row compression, and that will reduce your I/O. It will come with CPU cost. So the page compression has does a lot of some CPU work when you decompress and compress data to and for the disk. But typically, if I/O is the bottleneck, you will increase overall performance by implementing data compression, because your CPU cost will be something that you can afford, but I/O is the bottleneck, and total performance will then increase. So data compression is something we typically recommend. And also, you must be aware of that with SQL Server 2014 and earlier, that instant file initialization is not default, not in the Azure VMs. So it's important to enable that. This is a general best practice that we've talked about in many years, but it's not until SQL Server 2016 that we actually do something about the default settings in SQL Server. So now in 2016, when you run the setup, there's actually a question, or there's a checkbox during installation that says, do you want to enable instant file initialization? And we recommend that that is actually checked when you and then when you install SQL Server. But for all current versions, you need to actually go into local security policy, user rights assignment, and you need to make sure that the SQL Server service is a member of the policy perform volume maintenance tasks. And that essentially means that the SQL Server, the service, will now have the permission to, when it allocates space on the file system, it doesn't need to fill that space with zeros. It can just pre-allocate the size of the file. And that's very important for before you create databases. So you should do it's for restoring a database, for adding files to auto growth events. It's extremely important. It can reduce the time to perform file operations to from like 100 seconds to just a few seconds, just to have that permission. For some of you, it doesn't matter, because your SQL Server will maybe be already part of the local administrators group. So for some of you, it doesn't really matter, because you're already running instant file initialization. But SQL Server does not have to and should not be a member of the local administrators group. By default, the SQL Server service should just be ordinary member, ordinary domain user, and by default, then ordinary domain users do not have this permission. Okay. So we recommend that, first of all, that to avoid the whole issue, that all databases file will be that you pre-size them, that auto growth is delayed. And that you then configure instant file initialization to make sure that when you first have auto growth, or when you create databases or do a restore, that it happens as fast as possible. Other things we recommend. First of all, we recommend that we do not spread data files of a single database into multiple storage accounts, because then data in different blobs will not be written in the same time, and you can then have blobs in your stripes out of sync. And that could be an integrity issue if you have some failover situations. So it's important to make sure that all your files are in the same storage account. So just an example here. Here's an example of a customer who has a pretty large database, and they decided to allocate 16 disks. And here we see an example of using 6 of those disks for your TempDB data files, 1 for your TempDB log, and the rest for your customer databases, and then 1 for your user database transaction log. So 2 disks dedicated to transaction logs, and the rest spread between the TempDB and the user database. So this is the typical pattern you will see in performance optimized solution, where you have a pretty large VM, in this case 8 cores, 56 GB RAM, where they attach 16 data disks to achieve the performance targets that they needed to in order to match the performance of an on-premises DB server configuration. Just an example, just to see how it looks like. So what about hybrid cloud capabilities? So these Azure VMs, either the Azure VMs or on-premises VMs, they can have in SQL Server 2016 and also with in Azure, have super fast backups based on Azure stored snapshots. This can also be combined with database files that are not accessed locally in the VM, but are accessed on with data files directly in Azure storage. Now this is something that we supported both in SQL 2014 and also is so in the SQL Server 2014 you can actually have an on-premises SQL Server that has your MDF and LDF files in Azure storage containers. So picture that. You have your server here in Oslo, and then your D drive and E drive is actually stored in Amsterdam. But if you have that type of scenario, if that makes sense for you, because then you want, because of the bottomless storage you get in Azure and the zero failure and everything, then you can you don't want those backups to actually be data that is pushed to your local server here and then pushed back to a storage location. So Azure storage snapshots create pointers to files instead of read and write log, and then just moves these generates, and the data movement is actually happening in Azure storage instead of locally in the VM. But the same scenario can also be applied to Azure VMs. So if you have a large Azure VM and you are limited by the amount of IOPS that you have locally, you can just see that a database can also access data that is used in a separate Azure storage container, and then you can use backup to Azure with file snapshots in order to have an effective backup of that. So this is actually something that is pretty great. Also, not only the Azure snapshot storage technology, but also in general to back up to Azure storage is something that you should look into if you haven't already, because it's really helpful and very useful. So just an example here. Another hybrid scenario that is being a lot of customers are looking at is in 2016 we support something called StretchDB. StretchDB is that you have a SQL Server VM, and you can say that tables in the VM will be stretched to a table in Azure, and your applications still work on the local on-premises table, and SQL Server will then take the cold data, the historic data, and move it to Azure, and in order to save storage space and increase performance for your local on-premises SQL Server, or local on-premises or in an Azure VM. And when you then query the local table, SQL Server will join that data with the cold data that is in Azure and return you the full result set. Of course, that will come at a latency price, because it's of course colder. It will of course go a little bit slower, accessing data that needs to be joined from 2 locations instead of from 1 location. But it's a really good solution for a lot of scenarios. For example, ERP solutions where you still keep your transactions for 10 years ago because of compliance issues, but you don't actually need that data online. So this is something that a lot of customers are interested in, that will work with Azure, both SQL Server Azure VMs and because the SQL Server in an Azure VM doesn't know that it's in Azure or that it's in on-premises or where it is. It just it can access data that is in any place. So that is something we can also use to extend the capabilities of a large Azure VM scenario. So In the end of my presentation here, I have some general tips for for VM configuration. I think I'll skip that now since we're reaching the end of my presentation, but I'll keep it in the deck so you can use it as a reference if you download the deck afterwards. And there's also some pointers to some best practice white papers. We have in 2013 we have the performance best practices for SQL Server and Azure VMs, where some of my content is from. But this came out in 2013, so it's actually a bit outdated now. There hasn't come a new version yet, but a lot of this information still applies. But it's, of course, in my presentation, it's updated with the latest developments with Azure VMs, with the gallery templates and everything. So, so with that, I'll be around for a little bit more if you have some questions, or else we'll just wrap it up. Okay? Thank you.